For Singapore, securing a sustainable energy future is a major national imperative. As a renewable energy disadvantaged city-state with limited land and no natural resources like hydropower or wind, the nation faces unique constraints in its pursuit of decarbonization. This reality necessitates a comprehensive exploration of all viable clean energy options to power its infrastructure, drive its industries, and support the daily lives of its people. As Prime Minister Lawrence Wong noted, a generation ago, our critical constraint was water. Today, we face a different challenge. Expanding access to clean energy is therefore a major national imperative. The core framework guiding Singapore's energy policy is the energy trilemma, a delicate balance between three critical and sometimes competing objectives. Any potential energy source must be evaluated against its ability to meet these interdependent goals. Clean, to decarbonize the electricity system and meet global sustainability commitments. Secure, to safeguard the national electricity supply against external shocks and disruptions in the global market. Affordable, to keep electricity costs manageable for both households and businesses. To navigate this trilemma, Singapore is currently pursuing a diversification strategy across 4 key pathways. However, this portfolio reveals a set of strategic challenges that underscore the need for a high-density, reliable power source. Solar energy. Despite becoming one of the most solar-dense cities in the world, space constraints mean that even covering all available surfaces with panels would meet only up to 10% of the nation's energy needs. Regional grids. Importing clean electricity is a viable strategy but creates dependencies on regional infrastructure development and geopolitical stability. Low-carbon alternatives. Domestic options like hydrogen and geothermal energy are being explored, but remain in early stages of technological and commercial development. Natural gas. Constituting 95% of the energy mix, this fossil fuel underpins Singapore's current energy security, but directly undermines the clean objective and exposes the economy to global price volatility. Against this backdrop, advanced nuclear energy is emerging as a promising low-carbon alternative with the potential to address all three facets of the energy trilemma, meriting serious and objective evaluation. Singapore's official stance on nuclear energy has undergone a strategic evolution. A 2012 pre-feasibility study concluded that the large-scale nuclear power plants of that era were unsuitable for a small, densely populated nation. However, it also recommended that Singapore continue to monitor the progress of new technologies. Today, that recommendation has transitioned into a directive to actively build the national capabilities required for a rigorous assessment of the latest generation of nuclear reactors. As Minister in charge of Energy and Science and Technology, Dr. Tan See Leng, stated, "Nothing is off the table. We continue to keep our options open to all kinds of low-carbon energy, including, of course, nuclear energy." The renewed interest is driven by the potential for nuclear energy to align directly with the energy trilemma. Secure. Nuclear power offers a resilient domestic energy source. Its supply chains are mature, and its fuel can be efficiently and safely stored in large quantities, insulating the nation from shocks to the global energy market. This is a critical advantage for a resource-scarce island nation entirely dependent on global supply chains for its current energy needs. Affordable. Preliminary analysis suggests that the levelized cost of electricity could be comparable to pathways like natural gas, though this requires rigorous validation against specific deployment models. Clean. As a source of stable, clean electricity, nuclear energy generation does not produce any greenhouse gases. Of course, historical safety concerns, shaped by high-profile accidents at Fukushima and Chernobyl, remain a critical consideration. The core principles of modern reactor designs are a direct response to the specific failure modes observed in these events, such as the loss of external power and the reliance on human intervention. By incorporating lessons from these past incidents, the new generation of reactors features systems with significantly reduced risks. Understanding these technological advancements is crucial, as they form the technical foundation for a renewed, evidence-based assessment of nuclear energy's viability for Singapore.